I really believe this is one of the best opportunities for data scientists and AI engineers right now. In this video, I will give you an introduction to the LangChain library using Python. LangChain is a framework for developing applications using large language models. I will walk you through all the modules, then the quick start guide, and then finally, we will create our first app, which will be a personal assistant that can answer questions about any YouTube video that you provide it with. So what is it? It's a framework for developing applications powered by large language models, like OpenAI's GPT models. And instead of just interacting with these models using an API, so basically you ask a question, for example, this is what you do when you interact with ChatGPT, but in the background, it's just an API that you send a message to and then get the message back. That's how you normally interact with large language models. LangChain is a framework around that also allows your application to become data aware and agentic. So data aware means that you can connect a language model to other data sources. So for example, your own data, company data that you can build on. And agentic means allow a language model to interact with its environment. So it's not just asking a question and then getting information back. No, it's also acting on that information by using various tools, for example, that we will get into in a bit. And now, why would you want to learn a framework like LangChain? And I really want to get deep into this because I believe there will be so many opportunities if you understand this correctly. So I work as a freelance data scientist. And up until this point, basically, my job as a data scientist is to help companies, usually larger companies that have a lot of historical data, and use that to train machine learning models on. But what we're seeing right now with these pre-trained large language models like OpenAI's models is that also smaller companies without huge amounts of historical data can start to leverage the power of AI. And now me working as a freelancer, this provides me with a lot of opportunities actually to also work with smaller businesses, doing smaller projects while also still being able to make great impact for that company. And also with really large machine learning projects using lots of historical data, you also never really quite know what you're going to get. So actually a lot of data science projects fail. And I believe using these large language models for small businesses or even for large businesses will be a much more predictable way of doing AI projects because the model is already there, you know what it can do, and now you just have to provide it with extra information and tune it to a specific use case. So if you learn this, if you understand LangChain and more specifically the underlying principles basically of this particular framework, then I think you will set yourself up for many great opportunities to come. You can really make a lot of money here if you understand this correctly. So let's get into this. So I will start off by explaining all the different modules to you, all the different building blocks of the LangChain library that you can use to start building your intelligent apps. And after briefly explaining each of the core components, I will give you an example from the quick start guide within VS Code. So you also have an idea of what it looks like in code and how you can use it. And there is also a GitHub page available for this project that you can go to. Link is in the description. So you can clone it and you can follow along. Here I also explain how to set this up and what kind of API keys you need and how to set up the environment and install the keys in your .env file. So if you're not familiar with that, I would suggest checking out this GitHub page so that way you can follow along. But coming back to the getting started page over here. So these are all the modules in increasing order of complexity. So we will start simple and we will start off with the models. So these are the model integrations that LangChain supports. And there is a whole list over here that you can check out. But you have the models from OpenAI, you have, for example, Hugging Face, and a whole lot of other different models that are supported right now. So that is the first module. So now let's see what it looks like in VS Code. So I have an example over here where I load the OpenAI model from the LangChain library, and I can basically define my model by providing a specific parameter here for the model name. So for this example, we are going to use the Text DaVinci 3 model. And if you go to the API reference for OpenAI, you can see there are a lot of models that you can pick, a lot of models that you can choose from. I am currently on the waitlist for GPT-4. So once you get access to that, it will become even better. But coming back to the example over here, so we load our model and then we can basically provide it with a prompt. So let's say, write a poem about Python and AI. So let's first initialize the model, then store our prompt, and now we are going to call the model and put in the prompt. So it will now send out a connection to the OpenAI API with our prompt, and then it will give us back the result. So this is just a general way of interacting with these large language models, and something that I can also do in ChatGPT. So here you can see the poem that we get back from the API. So this is nothing new up until this point, but this is the starting point that we need in order to interact with these language models. Then next on the list is prompts, and this you can use to manage your prompts, optimize them, and also serialize them. So coming back to our project, we have the prompt template over here that we can also import from the LangChain library. And the prompt template, what we can do, we can provide it with an input variable and then a template. So what we can do with this is we can basically ask user information or get some kind of variable information and then put it into a prompt, similar to how you would use f-strings, for example, in Python. And this is just a nice class that you can use, and there are more things you can do with it, but this is just a basic example. So we can provide the prompt template over here. Let me clear this up for you. So what is a good name for a company that makes, and then between curly brackets, product? And then we see the input variables is product over here. And now we can call prompt.format, and then we can provide the product. So after running this, what you can see is that we now have the prompt, what is a good name for a company that makes smart apps using large language models? And then the third component is memory. So we can provide our intelligent app with both long-term and short-term memory to make it smarter, basically, so it does not forget the previous interaction that it has had with the user. So coming back to our example over here, we can import the conversation chain. So that is also from LangChain, import conversation chain. So how this works is we can initialize a model again and then start a conversation. And then we are going to call the .predict method on the conversation and provide it with an input. So right now the conversation is empty, but we can send this over and predict it. And what you can then see is that we will have a conversation. So there is a general prompt here. So the following is a friendly conversation between a human and an AI. The AI is talkative and provides lots of specific details from its context, etc. So this is already engineered within the library, and then the human says, "Hi there." And then the AI provides us with a response, and that is the output. So we can print that, and that is, "Hi there, nice to meet you. What can I do for you?" And now what we can do next is we have that output, and we are going to make another prediction by saying, "I'm doing well, just having a conversation with an AI." So let's run this. Here you can see the history. So first we have the "Hi there," then we have the response from the AI, and then you see our response here again. So what we've just entered. And now we can print that again, and you can see that now the AI is responding by, "It's great to be having a conversation with you. What would you like to talk about?" All right, and then next up is indexes. So language models are often more powerful when combined with your own text data. This module covers best practices for doing exactly that. So this is where it gets really exciting. So this was the example that I was talking about previously, where you can build smart applications for companies using their own data, their existing data. And we will get more into this in the example that I will provide at the end of this video. But for now, just know that there are document loaders, text splitters, and vector stores, and also retrievers. So this is really exciting when we start to work with our own data. But for now, let's continue to chains, which is another core component of the LangChain model. So chains go beyond just a single large language model call and are sequences of calls. LangChain provides a standard interface for chains, lots of integrations with other tools, and end-to-end chains for common applications. So this is really where we start to bring things together. So the models and the prompts and the memory, it's nothing that new, right? We've seen it, we can use it in ChatGPT, but now when we start to chain things together is when it gets really exciting. So what does this look like in code? So let's look at the LLM chain class that we can import from langchain.chains. So given our previous model setup and the prompt that we've provided, so coming up with a company name, we can now actually start to run this chain. So the prompt template was just for engineering your prompt. The model is just for making a connection with the API. And now we can chain this together. So let's quickly store this, then set up this chain. So we provide the model and the prompt as input parameters. And now we can run this. So let's try another example. What is a good name for a company that makes AI chatbots for dental offices? AI Dentech. Love it. All right, so now you start to get a sense of how you can turn this into an application. You predefine the prompt over here, and then you combine it with user input and run that using a chain. So you could already turn this into a web app. For example, companynamegenerator.ai. This is it basically. And now the trick here, the key is being really smart about what you put into these templates. So this is a very straightforward example. What is a good name for a company? But you can get really specific here and provide it with lots of information, really tailored to a specific use case to get the result that you are looking for given the user's input. And I will give you a good example of this once we start to develop the YouTube AI assistant later in this video. And then the last component, agents. So agents involve a large language model making decisions about which actions to take, taking that action, seeing an observation, and repeating that until it's done. So this is really where you get to build your own Auto-GPT, BabyAGI kind of applications by using these agents. And these agents can use tools. So there are tools, agents, toolkits, and executors. And tools, for example, we have all kinds of tools that are already supported straight out of the box. So we have Google searches, we have Wikipedia, we have Google searches via the SERP API, all kinds of stuff that we can use. And if we use these agents, they will use the large language model, so for example, the GPT model, to assess which tool to use and then use that tool to get the information and then provide that back to the large language model. There is even a Pandas data frame agent that you can use, and it's mostly optimized for question answering. So here you can see a quick example, and you can basically ask it how many rows are there. And then it knows that it can interact with the Pandas data frame, call the lang function to get the length of the data frame and then provide that as a result. So let's look at another example from the quick start guide. So if I want to start using agents, what I can do is I can import the initialize agent, agent type, and the load tools to also provide it with some tools. And then coming back over here, I can first list all the tools. So these are also on the website that was just showing you in the documentation, but here you can see the specific name that you have to use in order to provide the agent with that tool. And now let's say, for example, we want to create an agent and give it access to Wikipedia, and it should be able to do some math. We can set up the tools like this, then initialize the agent, provide it with the tools, the model that is defined over here, and then the agent type is zero-shot react description, which basically means that based on the prompt that we give to the agent, it will pick the best tool to solve the problem. So it will basically pick the tool on its own. And this is where it gets really interesting, because now you can provide an agent with a set of tools, and then it will figure out on its own which tool to use to come up with the best answer. So let's try this query over here. In what year was Python released and who's the original creator? Multiply the year by 3. And we only give it access to Wikipedia and math. All right, so now let's first run this. So let's see what it will do. So new executor. Okay, so it understands that it needs the action Wikipedia, and then you can see the input Python programming language. So it understands that that is the query that you have to search for in Wikipedia. Then it will get the history of Python summary. All right, so I have enough information to answer the question. So the final answer, Python was created in 1991 by Guido van Rossum, and the year multiplied by 3 is 5,763. All right, so this is really awesome, right? And this is beyond what ChatGPT or the GPT models are capable of, because we can get live information from the internet. And then also the results are stored as well. So here you can just see the plain text string. We now have that available. And now if we start to combine everything together, so multiple chains, multiple prompts, and then use agents to get information, also use memory to store everything, now we can actually build some really cool stuff. All right, so I'm now going to show you how you can create an assistant that can answer questions about the specific YouTube video. So coming back to the indexes, I've previously explained how these large language models become really powerful when you combine them with your own data. And your own data in this scenario, in this use case, will be a YouTube transcript that we are going to download automatically. but you can basically replace that transcript with any other information, and this approach will still work. So the LangChain library has document loaders, text splitters, and vector stores, and we are going to use all of these. So let's first talk about document loaders, and these are basically little helper tools that make it easy to load certain documents. And here you can see everything that is supported right now. So we have things like Discord, we have Figma, we have Git, we have Notion, we have Obsidian, PDFs, PowerPoints, but also YouTube. So let's first see how we can get the YouTube transcript given a video URL using this document loader. All right, so coming back to VS Code, we have the following video URL over here, which is a podcast from the Lex Fridman podcast where he talks to Sam Altman, the CEO of OpenAI. And I thought this would be a nice video to use as an example. So we are going to first read the transcript of this podcast, this 2.5 hour long video using the document loader. So for that, we're going to import first the YouTube loader from document loaders, and we're going to input the video URL. So let's run this and see what we get. So now we have the loader, and to get the transcript, then we call the loader.load method. So we call this method over here and then run that. And then that will run for a while. And now we can have a look at the transcript over here, which is basically a very long string over here with all the text in here. All right, so now we have the full transcript and it is within a list, and we can access that using the page content to get the actual string, the actual transcript. But now we have the following problem. If I run this to see how long the transcript is, we can see how many tokens there are in there. So this is the total amount of characters, and we can see that it's over 100,000. And now this was really a aha moment for me, because you cannot just provide this full transcript with over 100,000 characters to the API of these large language models. It's just too large. So if you want the model to be able to answer questions about this transcript, we have to find a workaround to provide it with the information it needs to answer the questions without sending the transcript in full. And that is where the text splitters come in. Because if you go to the API documentation, you can see the max tokens over here per model for OpenAI models. And if you use the latest model that I can use right now, so the GPT 3.5 Turbo, it's 4096 tokens that you can input to the API. If you're already on GPT-4, you can basically increase the token size, but for now we're stuck to around 4000 tokens. So how do we deal with that if we have a transcript of over 100,000 tokens? We can use the text splitter to first split this up in several chunks. So what this basically will do is I say, hey, we have this transcript over here, this size, but I want to split it up in chunk sizes of 1000 character each. And here you can also specify if you want there to be a bit of overlap. And if I run this, so let's run the text splitter, and then, first define the text splitter, and then call the text splitter split documents, and then put in that transcript that we've just created. So that is the object over here, the list with the document and the page content in here. And if I run that, so let's do that. And now I now have the docs. And what we can now do, if we have a look at what docs is, we can now see that it's just a list with a bunch of split up documents. So it has taken the very large transcript, over 100,000 tokens, and split it up into chunks of 1000. Okay, so that is the first step. Okay, so now you might wonder, okay, so we've split up the transcript, but we can still not provide it to the API, right? Correct. And that is where the next part comes in. And that is embeddings and vector databases. So this is quite technical, and I won't go into the details in this video. I will make future videos about this, because for now I want to give you a brief demonstration and overview of how to use this, and then later we can get more specific. But first we use the embeddings from OpenAI to basically convert the text, the splits that we have just created of the 1000 tokens long, to convert them into vectors. And vectors are basically in this case, a numerical representation of the text itself. So we convert the text to a vector of numbers. Then we will use the face library, which is a library developed by Facebook that you can use for efficient similarity search. we will combine that to basically create a database of all these documents that you see over here. And when a user wants to ask a question with regards to this YouTube transcript, we will first perform a similarity search to find the chunks that are most similar to the prompt that the user is asking. So what this means is that we have this database with all these factors, and we can do a similarity search on that to find the relevant pieces of information that we need. And now this is the critical key to working with these large language models and your own data. First, create a filter, a lookup table of some sort to get just the information that you want, and then provide that to the large language model with your question. So if we bring all of that together in this function, createDB from YouTube video URL, we can, for any given video URL, load the transcript, then split it up into chunks of 1000 tokens, and then put it into a vector database object that we can return using this function. Now, what we can then do next is we can provide this to another function, the getResponseFromQuery, where we use this database that we've just created to answer specific questions. So how does this work? Well, we provide the database and the query, so the question you want to ask about the video, to this function, getResponseFromQuery, and then we also have a parameter k over here, which defaults to 4. And here you can see the reasoning behind it, but that is basically to maximize the amount of tokens that we send to the API. And then, this is where it gets really interesting, is we perform a similarity search on the database using the query, and we return k documents. So given our question, it will go through all of these documents and it will find the most similar ones. So it will do a similarity search. And then what we do once we have all the documents, so 4 by default, we join them into one single string. And then we create a model over here. And now we use the GPT 3.5 Turbo model. And next you define a template for your prompt, like we've seen earlier in this video. And this is where you can get really creative. So in this example, you are a helpful assistant that can answer questions about YouTube videos based on the video's transcript. And then we provide the input parameter docs, which we will replace by the string that we've just created. So all of the document information. Only use factual information from the transcript to answer the question. If you feel like you don't have enough information to answer the question, say I don't know. Your answer should be verbose and detailed. So like I've said, this is really where you can get creative, and based on the kind of applications that you want to create, design your template over here. And basically by creating minor changes within this template, you can create entirely different apps for all kinds of industries. All right, and then the next step is to chain all of this together. And since we are now using the chat function, using the GPT 3.5 Turbo model, this is slightly different, but you can find everything in the quick start. So first it explains how you can use the general models, and then it continues with the chat models. So the syntax is a little different because here we have the system message prompt and the human message prompt. So this is nice to first define a prompt for the system basically. So that is the description over here, the template, explaining the AI, the agent, basically what it should do. And then we have a prompt to alter the question or the input that the human is providing. So I, for example, added answer the following question and then put in the question over here. So I'm not sure if this is necessary right now, but you can alter the input from the user as well. So that is how you would do it. And then it combines all of that into a chat prompt. And then, like we've seen earlier, we can put that into a chain, the chat and the prompt, and then we can run that chain again, also like we've seen before. And then we just put in the query and the docs that we have defined earlier. All right, so now we have all the building blocks that we need, and we can actually start to call these functions. So again, let's define the video URL, and let's first create a database from this video. So let's see what that will do. So it goes quite quickly. So it gets the transcript and then converts it. So now we have the database object, and now we can fill in a query over here and then call the getResponseFromQuery function to answer a specific question about this video transcript. So let's actually see what they are talking about. And let's say I don't have time to watch all of this, but I'm pretty interested in what they have to say about AGI over here. So I can come over here and listen to what they have to say, but I can now also come to this application over here, or this function, so to say, and then fill in what are they saying about AGI. So that is the query. And now let's get the response and let's print it. So there we go. In the video transcript, they are discussing AGI, artificial general intelligence, and the work being done by OpenAI to develop it. Sam Altman, the CEO, and so on. So it's answering the question based on the transcript. Awesome. So let's ask it another question. Who are the hosts of this podcast? So let's run it all at once. So it will do some thinking. First, get the response, and then based on the transcript, it is not clear who the hosts of the podcast are. However, it is mentioned that the podcast features conversations with guests such as Sam Altman, Jordan Peterson, and is hosted by someone named Lex Fridman. Okay, so this is really interesting. It is admitting that it doesn't have all the information, but it is recognizing all the entities, and it is correct. It's a podcast by Lex Fridman. All right, so let's try another one. What are they saying about Microsoft? In the transcript, the speakers are discussing their partnership with Microsoft and how they have been an amazing partner to them. All right, awesome. And now also this function, get response from query, not only returns the response, but also the docs. So it's actually quite cool. We can also have a look at the documents in this case, that it's using to get this answer. So for this, you also get the reference to the original content, which is very convenient if you want to do additional research or fact check your models to see if it's actually giving you answers that are correct. All right, so now we basically have a working app, and all you have to do is create a simple web page around this, host it on a server or a web app somewhere, and people can interact with this. So fill in YouTube URL, ask questions, and it will do that for you. And really, when I look at all of this stuff, my head really starts to spin. I have so many ideas because, for example, what you can do with this approach alone. Let's say you create a list of all the channels that talk about a specific topic. So for example, you want to stay up to date on AI. You list all the podcast channel, all the popular channels, and then you create a little script that every now and then checks if they have a new video public on their page, scrapes all the URLs, and then process all of those videos with these functions, and then really engineer your prompt in such a way that you can extract useful information from that you can use, for example, to do research or create a social media account, for example, a Twitter account where you tweet about the latest updates in AI, or even a YouTube channel where you want to talk about AI. You can really scout everything and then ask, okay, what is the Lex Fridman podcast saying about AGI? What is Joe Rogan saying about AGI? And you can do that all automatically. And then you can combine this, chaining it together with different agents to store this information in files on your... You can see, the possibilities are endless over. So like I've said, I am really going to dive deep into this because there are so many opportunities right now. And as I will learn, I will keep you guys up to date on my YouTube channel. So if you're interested in this, make sure to subscribe so you don't miss any future videos on this. And really, it's been amazing how many requests I'm already getting from companies to help them implement these tools, help them with AI. I've been getting tons of messages, so it's really exciting. So for me as a freelancer, this is a really exciting opportunity, a really exciting moment to basically also start to work with smaller clients, smaller companies, and implement these tools. And now, if you also feel like you want to do more with this, you want to exploit this opportunity and start to work on your own freelance projects, but don't really know where to start, then you should really check out Data Freelancer, which is a mastermind that I host specifically created for data professionals that want to kickstart, launch their freelance career in data, but don't really know where to start. So in this mastermind, you will literally learn everything you need to get started to start landing your first paid projects. I share all my systems and models that I've developed over the years to basically systemize freelancing in data, to make sure you never run out of clients. And you will become part of a community of other data professionals that are working on their freelancing career. And we are all here together to work on the same goals of making more money, working on fun projects, and creating freedom. That's what we're trying to do here. Feels like hanging out with friends, but with real business results. So if you consider freelancing or want to take advantage of all the amazing opportunities that are out there right now in the world of AI, but don't really know where to start, then check out Data Freelancer, first link in the description, and sign up for the waitlist.